Welcome again, everybody, to the complete and absolute best free Flutter course on all of YouTube, or dare I say, all of the internet. That remains to be seen. I have an absolute banger of a lesson prepared for you today, not only because of the material, but also because since this is going to be lesson 6, since next time will be lesson 7, which is a complete week of creating this new channel, I'm going to give you guys not an exercise like usual, but a challenge. That is correct. I'm going to give you guys a challenge at the end. It's going to be like an exercise, but on steroids. So be sure to stick around for that, because I'm going to tell you, it's not as easy as the previous ones. Some of you guys, I'm sorry, some people are just going to fail. Some people are going to try to do the challenge and they're going to say this is too difficult and they're going to give up and they're going to miss out on so much learning, so much wisdom, but not you. The person listening to this, I know you guys are going to stick through, you're going to do your best, you're going to go through it, and you're going to have amazing results and you're going to learn so much from it. And I'm really looking forward to that. But before I can give you guys the challenge, well, we have a lot to get through for material. And really quickly before we jump in, I do want to remind you guys that, as always, the code is available from my GitHub. The link is going to be in the description below. So if you do want to look over that, if you want to copy paste anything, go ahead and do that. With that said, let us jump straight in. Today we're going to cover Boolean algebra, operators, and loops. And again, that challenge at the end is going to be amazing. I know you guys are going to love it. But to begin, Boolean algebra. What is Boolean algebra? I don't know if you guys remember from previous videos, but there is a data type called bool. And bool is short for Boolean. A Boolean value is either true or false. It can't hold anything else. It's just true or false. And Boolean algebra is, well, algebra done with these two values. And there's not really too much to it. And we'll just start out by saying bool t equals true, bool f equals false. That's just so we can calculate things easier, save on some typing. And Boolean algebra consists of 3 operations. The first of these operations is the AND operator. So this is pronounced and it's written with 2 ampersands in Dart. In other languages, it's a bit different. And what AND does is it returns true if both sides of the operation are true. And let me just capitalize both so it's really obvious what we mean. So if we say if t and t, then print this is true. So obviously t and t, they're both true, it's going to print out true. But on the other hand, if I said t and false, this would not do anything. If we did this line of code would be skipped and we would go to the next line, because this will come back as false. And one more thing about these operations. So AND needs to have 2 different things to evaluate, a left side and a right side. And this is also true for the next operation, which is OR. And OR is written with these 2 lines. On my keyboard, which is the UK keyboard, it's between my Shift and Z character. I think it's the same on an American keyboard, but it might be different for different locations. So what does OR do? OR returns true if either side is true and false otherwise. So if we say if t or f, well, this is true. And in fact, let me update this one here to say false, because in this case it is false. So really simple stuff so far. And there's only one more to go over, which is in fact something we went over last time. I'm not sure if you guys remember. And that's this exclamation mark. And I just need to add some kind of symbol before this because of my extension. So this is pronounced not. It's called the bang operator. And unlike and or, it doesn't take 2 things, it only takes 1 thing. and it will return the opposite of the value. So if we say if not t, which is false, print, this won't print because it's false. So in fact, it would be better to say if not f, and now this is true, then this is true, right? And of course, we can combine all of these however we want, but when we do that, we'll have to use the brackets to be really clear in our intent. Let's try something just to test our knowledge. If we say if f and t, or not t or t, well, pause the video here and figure out if this prints or not. What do you guys think? Is this going to print or is this not going to print? Go ahead and pause and I'll tell you guys the solution in just a second. Okay, so we're still here. If we're still here, I really hope you guys figured it out. Well, let's see what gets printed actually. We can type in my command line dot v6 vid 6 dot, and we can see the previous outputs, and it says pause the video here and figure out if this prints or not. So this came back as true, and let's try to figure out why that is. So it says false and true. So this first part evaluates to false because they're not both true, right? But then we have this or. So if this next part will evaluate to true, it counts, but if not, we won't do it. So this one, false, so that doesn't count. Or true, well, true is true, so we can use this, which means this side is true, so because of the or, this does get printed. So that's almost it for the Boolean algebra. It's not terribly complicated things. The only reason some people find it a bit complicated is because it's not constrained to using just Boolean values like we do here. We can also use regular operations like equals, less than, greater than, less than or equals, greater than or equals. So oftentimes you end up with complicated things like if, let's say we have some kind of number, if some number greater or equal to whatever, and blah, 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 blah. You know, you can get all these complicated things, and then it can be a tiny bit difficult to reason through simply because we don't know just from looking at this what the value is, unlike our examples where it's pretty obvious. And one of the reasons we had to go through this before the loops is because of our first type of loop. So the first loop we're going to learn is the while loop. What we do here is we just type while, and then in brackets we have some kind of expression, so it has to evaluate to true or false, and then here within the function body something happens. In this case I'm just printing out something happens, and I'm just going to comment all of this stuff out so we don't get extra output. And what's gonna happen here is that as long as this operation is true, then this thing will happen again and again and again. But as soon as this operation turns to false, our function will stop running. If I do this and run this, you're gonna see it just keeps going and going and going, and it's never gonna stop. Unless my computer blows up, it's just never gonna stop. So why did I do this? Did I just break my computer? No, we can stop the execution of any program by hitting Control and C. So it doesn't say Control, but you can see it has ~C. That's what I pressed. Control plus C at the same time to break out of a program, at least in your terminal. It's the same in Windows, it's the same in Mac, it's the same in Linux. So that operation will probably save your life when you're practicing loops. And I'm just going to type what this does. So while true, print or repeat function body as long as operation is true. Now, obviously, the example I gave you guys is it's a bit strange. I don't think we would do something like that. You will often see while true and then just have something constantly running, like some kind of listener or something like that. And then only when the user hits exit from the main program, then it will be stopped. So you will see that oftentimes, but not exactly the way I wrote it. Okay. A more concrete example, which will also lead into our next type of loop. Let's say we have a big number, and it can be whatever number we want. And let me just comment this out because it will break my code. Then we can say while big number over 10. And then we can say print and put something here, big number modulo 10. So what this is going to do is it's just going to print the last digit, in this case 3, and then we can say big number equals big number floor divide by 10. And what do you guys think is going to happen here? What do you think will get printed out? Well, let's see. We'll get 3 the first time it runs, and then you can see the output here. And then after that first time, it's going to take our big number and remove the 3, so it becomes 12. And it says, is 12 bigger than 10? Well, it is. So print the final digit, which is 2, and then big number equals big number, and divide by 10 again. So now big number is 1. And then it takes 1 and says, is 1 greater than 10? Well, it's not, so it stops running. So this is how you probably do a while loop usually. And I'm just going to write it to remember. So currently big number is 1 because we changed the number earlier. Which leads us to our next type of loop, which is the do while loop. And the do while loop is pretty similar, except that, let me just write this out, do while loops always run at least once, right? So it can run more than once, but it must always run once. So if I just copy this, and let me just add a print statement with some just some kind of breakage, so we can see which part is which part. So we can see from the first loop we have the 3 and the 2, and it doesn't print that 1 because 1 is not greater than 10. But then when we get to the do while loop, it does it first, it prints the 1, and then evaluates it afterwards, right? So doing it this way, we do get the 1. But if we were to get rid of this and start with 1, 2, 3, you'll see that we will get the same output as we did from the while loop, 3 and 2, because it's only guaranteed to run once, but it will still evaluate it before running it again, afterwards. So you can see if we do need it to run once, so when we had just that 1, the do while was a good choice, but oftentimes it will be quite similar to the while loop. In fact, usually it's the same as the while loop. But to be fully honest, personally, I don't use either one of those. And I think many people feel the same as me. The most common, I'm just gonna comment this out. The most common type of loop you'll see is the for loop. And the for loop is going to come in 2 different variants in Dart. So let's say we have an int small number this time equals 5. To make a for loop, we'll say for, open and close parentheses. We can have our function body there. And this will take 3 arguments. The first one will be a variable declaration. So I could say int I equals 0. And then I need a semicolon. Rather than the usual comma, For the for loop, I always use a semicolon to separate these three things. And then I have some kind of comparison next. So I could say I less than small number, semicolon again. And finally, I can modify the variables in some way, I++. And if you haven't seen it before, I++ adds 1 to I. And then in here, I can print I, so we can see what happens. And if I just run this, we'll get 0, because that's what I is the first time, 1, 2, 3, and 4. So then, once I is 4, it's printed, it has 1 added, so now I is 5, and it says, is 5 less than small number, which is 5? It's not, so it does not get printed again. Now, you might be wondering, why I equals 0, not I equals 1? Well, it's a long story. For now, let's just say, for us programmers, we always start counting at 0. So programmers always start counting at 0, not 1. If you try counting a 1 in the for loop, it will still work, but in other things, it's just going to cause you all kinds of problems. So I don't want you to think in that way. Always think of counting as starting with 0 in programming. Always, always, always. I want you to have that habit. Never type I equals 1. It's not right. Okay, so I did say there's one final type of for loop, or one different form, and I'm just gonna comment this out. And the final for loop, it's similar to the previous one, but it will calculate some things for us. So let's say, for example, I said string, temp string equals whatever, could be this. And then I can say for, and I'll have some kind of variable in something else, some kind of list or something like that. So I do need to declare it. So I'll say string C. C is short for character, but I can just write char as well, in temp string. And if I just do it like this, it's going to give me an error because temp string is a string, but it wants it to be an iterable, some kind of list. Now, thankfully, it's very easy to do that. I can just say split, and I'll split it on, I just have the empty single quotes. So what this does is it will split on every character. Let me get rid of one VA so you can see what I mean easier. Okay, and then as always, open and close our curly brace, and inside, let's just do something like car times 2. And one thing I do also want you guys to notice is that you can multiply a character or a string by 2. It's perfectly fine, or multiply it by anything else. So if I run this, we're going to get the first character A twice, S twice, D twice, and F twice. You can see the output out here. So this final for loop was for, I'll just type it here, for variable in some kind of list or some kind of iterable. Wow, okay, so we learned a lot in this lesson. Real quick review first. So we went over, and I'm gonna quickly uncomment everything so we can see it. We went over Boolean algebra, operators, and several different kinds of loops. So for our Booleans, we have true and false. Our Boolean algebra is and. 2 truth values are truthy, and if it's one truth and one false, it's going to be false. We have or, which returns true if either side is true. We have not, which gives us the opposite of whatever we give it. We can combine this in all kinds of interesting and strange ways, and this should be commented out. Then this is an infinite loop, so be careful with this. And if you do have an infinite loop, or if you want to close a program for any other reason, if it's running in your terminal, hit Control-C, and that will stop it from running. Then we have while loops. So the while loop will do things as long as this is true, what we often do is change the variable we're comparing inside the loop body so that it does eventually become false. And this is slightly different than a do-while loop, which is basically the same thing, except it will always run at least once. It can run more than once, but it will always run at least once. And then we have our, there should be a comment, our for loops. And for our for loops, this is the usual format, which is for variable, initialization, comparison, and change variable. So this is the way we normally do our for loops. And this is the old C syntax, which everybody's familiar with. And the newer way of doing for loops is like this: for variable in some kind of list. Okay guys, so as I promised, there is a challenge, not an exercise, that is correct, but a challenge. And what we're going to do is we're going to combine everything we've learned so far to make something a lot bigger than our previous functions. But there is one thing I need you guys to know before we move on to that. And that is how to make a new line. If we say string str equals, and then if we have /n, what this will do is make a new line. So that will make my string go to the next line over here in the terminal. When we use a print statement, it does that for us automatically. But if we try to make a longer string, it won't do that for us automatically. So I hope that makes you curious. So for our challenge, what we're going to do is build a pyramid from a given character and a given height. And there are going to be some constraints, and let me just show you guys what I have so far. I'm going to uncomment the import at the top. So if I print, I called it build pyramid, it requires a character and a height. So for the character, I could type in, for example, this. For the height, I can type in 50. But it also has one optional argument. We can do this, height 24. It also has the optional argument to sides, and I can pass in true here. If I don't pass that in, it's going to be registered as false. And let's see what this does. It's going to give me an error, that's what it does. If I get rid of this because it doesn't have the semicolon at the end, and I don't need it anyway, and try it again. Apparently I forgot to comment all of this stuff out. I'm going to get a lot of errors here, as you guys can see. Okay, but this time it's definitely going to work, I promise you guys. So it creates a nice pyramid for me. So this was the first one with all of these with a single side. And this is the second one. When we have two sides, it's going to mirror it with two spaces in between. So what do you guys think? Can you guys do that? I'm sure you guys can. But of course, there are some constraints to it. For example, to make it looking nice, there is a limit to how long, to how high it can be. If I say, for example, whatever character I want and a big number like that, this would break my terminal. So it's going to return base length must be between 1 and 50. So it does not print the pyramid with this, but instead just tells me it can't do it. And it tells me why. I have it hard coded as 50 being the max, but you can have any max you want. Or we can also, if we try saying a longer string with something like this, you can see it says character must be of length 1. So if I have a longer string, it's not going to let me do it. Let me just get rid of this as well. And the reason I'm not letting us have a longer string is just for simplicity, because what would happen if we try to do that is probably something like, so this one doesn't have the constraints, so we can just see what would happen. Yeah. you can see it doesn't look right. And this is even without the two sides. Let's see what happens if I say two sides is true. It's going to be even worse. What is this? What is this? Honestly, this doesn't look right. So you can see that if we have the character being too long, it will cause problems. It can be fixed, of course. So I did do a build pyramid fixed with this one. And if I just say 10, two sides true, we can fix it. But it is just a little bit more complicated. It does have a bit more code. So I thought that instead of asking you guys to do all the fixes, we'll just say if it's longer than one character, we can't do it. Okay, so once again, it's going to be super simple. I'm just going to demonstrate one of my favorites, this one. We are going to build a function which will return a string which builds a pyramid with either one side or two sides, and here we have our two-sided pyramid of a given height, and the base here, the length is the same as the height. Okay guys, so I look forward to seeing your results. I'm sure it's going to be amazing, and be sure to tune in for the next video when I go over several different solutions to this with the fixed and the broken ones, and it's just going to be amazing. And guys, if you can't do it, then that's perfectly fine. I do understand it is a bit more complicated, but do your absolute best. You will learn so much. So guys, that has been it for today. Thank you so much for tuning in, and I will see you guys next time. So for now, myself, Avidius, am out.